Okay, let's get started. Thanks everyone. Um, so in this birds of feather session, right, Niranjan and I are going to talk about account eventing pertaining to a few clients that we've worked with, but primarily or for one of our airline clients. We're going to talk about some of the challenges that we faced, which probably align to some of the challenges which we have seen in previous sessions today, but some new interesting situations as well. We'll talk about how we leverage eventing, how it integrated with a lot of downstream and upstream systems, like what were some edge scenarios that we faced, lessons learned, and go through that, right? So that is going to be our approach here for this session, where we will talk about, give you a quick context overview of what the problem statements were. We'll talk about here the solution approach. We'll talk through this through two scenarios, and we'll also talk about some of the challenges with data consistency that we observed, which needed to be addressed, right? Quick question. So we both of us work with Capgemini Consulting. We are passionate about technology. We focus on building technologies for our customers. We are partners with a number of large vendors here, standard stuff which you can see on the net. We have a lot of global cloud capabilities, building solutions for a large number of clients. Uh, this is us with much better lighting in a studio setting. Our contact details are, of course, provided here. We come with a deep experience of working through a number of clients across a number of industries. I'm out of Seattle, and Niranjan is out of Atlanta. Niranjan, you want to do a quick intro?
Yeah, good evening, everyone. Good afternoon, everyone. So, I'm working as a delivery architect within Capgemini. I have worked with various North America clients transforming their business from on-prem to cloud native. So, yeah, I work with various cloud native platforms. That's my brief intro.
Sounds good. Now, what we want to look at is, right, when we are building event driven solution, right, it's not about just the core concept of like having a solution which sounds cool if it doesn't perform. So the focus should always be on how we are solving the business problem which is being faced, and in some situations focusing on challenges which are upcoming, right? In this situation, right, we've talked about a lot of clients, right, in terms of challenges that they face. Some of the key capabilities, right, which we've seen is like they are not able to channel and manage inventory management, right? So they were basically having a legacy solution which could not manage inventory correctly, which could not manage routes correctly, and which was not truly scalable in terms of their future needs as the client itself was growing, right? They were trying to expand both domestically and international markets. The growth capability was very hindered because truly they could not manage the scale of data that we were looking at and integration perspective itself, right? um, so that said, right, they also were looking at efficiencies around managing how availables are. So if what you would look at is like an available is things which you typically would see whenever you do a shipment through an airline, or even when you're shipping bags, right, you would see a tag which would have an airwayable component, right, which typically a barcode or some kind of label. Now that determines the unique piece of cargo that is being shipped. And today, right, like there are like tons of cargo shipped, right, like hundreds of tons shipped every day, and a lot of it has to be efficiently managed. Some of them are perishable, so there's a lot of efficient management which is needed to ensure that the transportation becomes optimized. And as we know, in COVID situation, right, the number of flights that are flying are severely restricted, right? So that efficiency needs to be managed as well. uh, Now, coming to the solution itself, right, the solution comprised of a lot of the blue boxes you can see in the middle, which we built out, transforming the experience, the underlying microservices, the eventing based solution as well as the persistent stores, right? So we covered a ton of services across end to end. Our focus for this session is going to be around the middle area, around how we manage to use eventing, as well as how we are going to integrate with the backend data services. So that would be our core focus for today's discussion. Niranjan, you want to add anything?
Yeah, so the core focus would be on the middle layer, whichever is highlighted in blue. So we are going to look in detail further in the slides how these services are broken down and how the Akka patterns were integrated. Yeah, we can move on, Mukund. I think
Sounds
let's
good.
go.
So, at any engagement, right, when we are looking at building solutions, we need to have some standard principles. Our principles, while they were focused around a lot of areas, we called out some of the key focus principles around how we would build out the event-driven architecture, so standard eventing-based principles, right? Now, from our perspective, right, what we were looking at is once we've identified the principles, there were a few integration patterns, right, in terms of how external systems would provide information to the solution itself, right? Typically in this case, right, we would have events come in, and a single event could have multiple impacts, right? Like, say for example, if I had a gate change event, for example, from a flight schedule, that could impact all the variables for that given flight. So there are multiple consumers who get affected by that. Or a simple capacity change would impact multiple flights which are set up. So there's a lot of like trickle down effect which needs to be managed when these events are happening. So what happens is we are both the consumers of a lot of events, and some of the events that we produce from a solution perspective would typically be handled need to be handled by downstream systems as well. So these patterns provide us a roadmap in terms of how the integrations need to happen, and how the data needs to be correlated and persisted, right? Which is where eventing truly comes into picture, and we are going to talk about some of these in upcoming slides, right?
Right.
So
So
here, when we are looking at the existing scenarios, right, our core focus is leveraging Akka design with everything, like we'll leveraging the source and sync pattern, which we'll talk about in capacity, the flight schedules. We will also talk about some of the processing rules of how we did it and how we managed exceptions, right? So if a set of transactions failed, what is the poison approach which we took in terms of rollback, etc., right? um, Key thing, right, again, understanding the breakup of responsibilities is a key aspect, right? We don't want to come back and build a complex solution which truly doesn't handle eventing in its true source. So that was a key goal when we were looking at building the solution in a very optimized manner. So let's jump into the first scenario from a capacity perspective. Niranjan, you want to talk about this?
yeah, sure. So for airlines, capacity and schedules are like the major inventory. So if you consider capacity, right, there could be two different scenarios. One, you're coming up with a updated airway bill where you want to request for new capacity. That's like you decrement the actual capacity which is available on that flight or flight leg and assign that to a customer. So that's one scenario. Or there could be another scenario where you're coming up with a new booking. So we had few complex scenarios like we need to handle allocate capacity at a service level. Like you can have different customers that could have been identified. One customer can come with a service level of rush or next flight guaranteed. So we need to ensure that when customer comes up with a request of booking, the capacity is allocated, pre-booked or pre-allocated for all these different service levels. And when the capacity is requested, we book against the specific service level. So that's the scenario that capacity that we were trying to handle here.
Yeah, and why that is important is truly, right. It's truly from a sales perspective, right? You need to manage inventory correctly so that you're able to allocate the capacity at the right level, and to be able to charge the customer appropriately, right? So that you're able to provide them the right billing for the right booking itself, and you're not double booking, or you're not leaving flights with a lot of unused capacity, right? That optimization provides the ability for these organizations to manage that inventory very well. And especially when we look at it, right, in a growing situation where you're adding new flights, or when flight routes get changed frequently, the management of this becomes very important. So let's talk about these scenarios, right? Niranjan, you want to talk through the booking and the canceling scenarios?
Yeah, so yeah, there could be two different scenarios. One is a booking. Say if a new booking is requested. So what we do, we look at the total capacity that is available for that flight. Out of that, we take out some capacity. So it is like reducing the capacity, or the other scenario is incrementing the capacity. So these are the two scenarios that we can have in terms of booking. And canceling, you are actually putting the um, capacity back on the flight. Say if a aerobill gets cancelled or flight get cancelled, the entire capacity goes back to the bucket. Yeah. So as part of this capacity booking, there could be two different transactions that's going to happen. One is who actually booked, like the audit trace itself will be logged as a transaction, and also we log one more event into Gemfire. So we are using Gemfire as the middleware. So it acts as a active persistence layer, and all the transactions that were done on the capacity module, we were storing it in Gemfire.
Hey,
So
Niranjan, let me quickly interject on that front. I
yeah,
think it's a good segue before we jump into the details here. So as you can see on the left here, right, the event generation systems could be external systems in terms of providing the capacity decrements. Now we had adapters which were set up to handle those events and persist into Gemfire. Now the key need was the we considered using TIPCO. They had a middleware service as well, but in a case where we if they had truly active TIPCO, then we could have used that. But in this situation, they didn't have active, so we had to use Gemfire, which was the truly only active solution across across the multiple regions in their private cloud, to be able to handle that the transaction consistency. So in a situation where you are looking at it, you may have situations where middleware is provided in an active situation, so you could truly leverage that. Go ahead, Niranjan.
yeah, thanks, man. So I was saying there are two transactions that were getting saved. One transaction is being the event itself. So once the transaction is persisted, there could be different consumers who can process that event and take necessary action. So one of the service that we had built using Akka framework was the capacity service. Anytime there is a transaction happening and saved on Gemfire, this Akka system would come into picture. It will pick up that event and then persist. So why Akka, right? So there could be thousands of transactions happening per minute. So we wanted to do everything in non-blocking ways, such a way you process these events across various actors and save it in the Gemfire so that you're not blocking any transactions. And some of the design considerations that we did, given Gemfire is our data store or data sink, we had to retrieve these events and process in the Akka system. So the option one was to configure a CQ. So Gemfire provides a continuous query. So we can configure a CQ on Gemfire, and Akka system will configure a CQ listener, which can get all the events that get stored on the Gemfire region. And as soon as the event is saved, the CQ listener on the Akka system will get that event, it will process, and it will save. One drawback with this option is whatever events, say if Akka system goes down and there are transactions happening and getting saved on the Gemfire, so during that time, the events will not be pushed. Or once the Akka system comes back up, the events that were done during the transactions that were done during Akka downtime, those won't be sent as part of CQ. So the option one was ruled out. Second option that we considered, we'll have CQ, for all the events. When system is up, we can get all the events. Say if system is down, we can configure OQL, uh, and then fetch all the events and process those events first, followed by all the CQs. So we needed a way to checkpoint and say all the initial events are processed. Uh, Past that, you process the CQ events. And third option, we can directly configure a OQL and then query the events and then process them and do a checkpointing. Saying once the event is processed, you go and update in Gemfire region saying these events were processed and you can proceed with the next one. Like when if even if the active system goes down, you can have once it comes back up, we since we have already stored the checkpoint, we can go retrieve the checkpoint, which event was last processed. You retrieve that event and move forward. So that way we can, yeah,
Yeah, I think like you talked about some of the key aspects, right, around how the ability to process the steps themselves in parallel or sequence. I think some of those key items, and more often, right, a lot of times you would have a lot of events. Like say, for example, you had two events, right? Like one, like for whatever reason, there's a available which got cancelled. You got capacity, which got released, but then you had another one where another available was booked and capacity got incremented. You want to sequence them in the right way so that at the end of the step you're able to book it right with the right capacity. Like say for example, if I'm trying to book a 1,000 pound cargo, right, yeah, and if I have only 800 pounds, I should not be able to book it, right. The synchronization needs to be set up that the booking should happen only if I have the required capacity. Let's go here, right. So in terms of how the two transactions are being persisted, right? So Niranjan, do we want to talk about in this situation, right? Let's talk about how uh, this is managed, right, with event broker 1 through n.
yeah. So so the entire system, right, cargo system, it was persisting all these events in Gemfire, and you can configure multiple event consumers, and each consumer can query those same events and process them only if it is required. Say you can have capacity as one Akka system which is configured, and you can have one more, say for schedules, flight schedules. So that also you can configure as a event consumer Akka module, and you can retrieve all these events parallelly and process them. You don't have to rely on one Akka system to process everything. And if any events that doesn't belong to, say, capacity service, when it is processing all these events and it comes across flight event, so it can simply drop it and proceed with the next one. It doesn't have to process that event. So whatever domain specific Akka system, it can process only those domain events. So in this example, we have depicted two consumer events. You can have up to n. You can have as many consumers as you need, but all of them will work on the same event stream. It will process those events if it is applies to that specific Akka system. Otherwise, no. And you can have multiple patterns here. One is you need to process those events in sequence, saying, say, if there is a flight which is scheduled, and if there is a change in timing, say gate timings is changed or gate number is changed, we need to process those events in order. So that's one scenario, and you can have some events which can be parallel. Um, so each Akka system, we can configure it. We configure it to process either serially, parallelly, based on the use case that we are trying to solve. And we have one more pattern here where we also had external consumers. So we publish it to a event topic so that any external consumer who wants to consume these messages, they can do so. So this is the securest pattern that we had along with this Akka async brokers. So all the microservices that we had configured saves events in the Gemfire, and Akka async brokers that we had configured retrieves these events and then saves it on the DB. So this is the The earlier one is the command pattern, where all the microservices are saving the events. And we had these query services which can directly go to this Oracle DB and retrieve all the reporting or analytic needs. So this is a very high level class diagram. Whatever is represented in pink is the standard framework that we had built so that the same classes and um, functionality can be replicated across multiple consumers. And one important one is the event dash where you can refer. So anytime there is a once the Akka system or Akka actor system comes up, we go retrieve all these events and then process them one by one. And then the ones in gray are all the features that we are using from Akka, and all the pink ones are the framework, and the same classes can be used across actor systems. And if you look at the last one here, capacity service, check capacity, that is specific to a capacity module, say capacity consumer. So we had built these business services separate, and we had built these Akka framework modules separate, so that you can reuse a majority of these Akka um, modules, Akka classes across multiple actor systems, and only you rewrite only the business logic which is required per service. We don't have to redesign each and every Akka system every time.
I think to go back to your point, right? Like one of the key challenges we faced was like, hey, when we had to look at we were looking at first domestic and then international transactions. So at that point of time, when we were looking at international transactions, so all we needed to do was have another broker, another actor system to be able to perform the processing. So it was just an incremental change, like from our implementation perspective, right?
Yeah.
So let's look at so what we're going to look at here is few key components in terms of patterns, right? How we built out the solution itself. We will talk about some of the key patterns and some of the lessons learned in terms of how these components were built out, uh, right? Niranjan, you want to talk about this?
Yeah. Yeah. So this is the key file where we configured all the Akka configuration in application conf. And one of the um, key configuration is the mailbox type that we had. We needed to have all the events processed and each and every event to be acknowledged. Otherwise, the system, for any of the sequential event processing, we wanted to make sure all the events gets processed and they are in sequence. So we use this peak mailbox type so that message gets reprocessed until unless the mailbox with explicit acknowledgement. If you're not sending acknowledgement, the actor system was retrying until it gets finally processed. So that's one. And we use the pin dispatcher. That was the standard recommended by Akka system for processing large events. Yeah, so this is on the remoting. So we had a cluster setup where we had four nodes running, two on the primary data center and two on the secondary data center. And we had configured a master and a slave configuration where master gets all the events and creates actors across cluster. So we used remoting to ensure the actors were spread across and gets processed parallelly. Yeah, so here if you look at this enable transports, we had NITI TCP to ensure all the actors will join when the actor system comes up, it joins into a cluster. Yeah, so this is the consumer initializer where once the actor system comes up, it uses the configuration in the pin dispatcher, whatever dispatcher we are defined, and also when system goes down, it leaves the cluster. The one actor system will leave the cluster.
Yeah, so this basically provides a scalability aspect, right, Niranjan, in terms of how
Right.
we are able to scale it up. And the second part, I think, when we go back here, right, there's a the sizing aspect as well, right, around how many uh, nodes that are needed. I think a lot of it is going to be
Yeah,
uh,
here.
around the experience, right, in terms of saying like, hey, how many nodes we would truly need, and there's a performance testing aspect as well, uh, to be able to understand what is the throughput that is needed. Um, we'll talk about a little bit of that when we go into the flight schedules.
Yeah, so yeah, one more point on that remoting, right? Say, if you want to include one more node or say five more nodes to be added onto the cluster, we just need to update those host names and then start that actor system. It will automatically join the cluster and then it'll start processing. We don't have to do any extra configuration.
Got it. We look at a couple more components right here. So we talked about the initializer and the consumer, but what I want to also jump on is to the DAS as well. Right, Niranjan, do you want to talk about the DAS?
Yeah, so this is the key component that we had built to make sure all the events gets processed in order or in parallel. But the key component here is the checkpointing to make sure once the event is processed, we go and store which event is processed and what is the state, so that when consumer goes down or once it comes back up, it can go retrieve all the checkpoint where it is currently and then retrieve the events further down and then process it.
Yeah, and I think Niranjan, I think where like if we look at it hypothetically, right, this is more around um, not focused on the actor state, but more on the event state,
Right.
right? So you're putting a premium on the processing of the event, and this is truly where the power of Akka lies, so that you're able to handle a lot of events, and not worry about how scalable your actors are. And secondly, right, like a lot of people try to solve it using microservices and building their own components, which is truly an anti-pattern in terms of an approach, right? When you have a scalable streaming solution like Akka to be able to manage checkpointing, to be able to do the peaking itself. Uh, let's go into the broker actor.
Yeah, so this is where we configure the a strategy and also pre-start where we are configuring all the dispatchers and when it is coming up and what is the checkpoint based, is it time based or I think there was one more I forgot. Yeah, there were a couple of other checkpointings that we had, different various configurations. So we went with the time based checkpointing, saying at this time till when the event is saved, we had event create date and time. So based on that, we used to retrieve all the events, and there was I think a ID based, sequence based kind of a thing. So we went with time based, and when the actor system comes up, the actor will initialize the checkpointing and all the strategies here. Yeah, so this is the key, another key component. So are the methods where once the event broker is up, so it'll start receiving the messages. So once the message is received, we are going to invoke the corresponding business service. Say for capacity, will invoke the capacity business service, which can be reused. The capacity business service itself is reused across the application, but this actor system will invoke the existing business service instead of rewriting a new one, so that the same logic can be used across. Yeah, so this is the capacity worker actor I was referring. So this will invoke the capacity service, and once the domain event is retrieved, it will identify whether this domain event belongs to capacity service. If it is true, then it will process. Otherwise, it will drop, and it will move on to the next one. Yeah, so the exception handling. So there are a couple of use cases that we need to handle here. One is the poison pill approach, where you received some random event that gets saved. We don't know how that event gets processed now. So we apply all the business rules and make sure whether it belongs to capacity service or not, or it confines to the model that we have defined. If it is not confining, then we're going to drop it. We're not going to process. And any other resource failure exceptions, right? Say your Gemfire is down, or your queue is down, or ESP is down. So these scenarios, we had configured a retry count, max retry count, and retry count. And then if the service is unable to connect to any of these resources, it will shut down itself to safeguard itself. And then someone, and we are going to raise alarm, and user has to go in and make sure, get that service up and running, say Gemfire or ESB. And then Akka system, once it comes back up, it'll start processing. I mean, this is a specific use case which we needed to implement based on the client requirements. One of the integration pattern that was provided by our client. So this is the pattern that we used. So we discussed mostly around event consumption. So there is a event publishing piece as well. Say if you want to publish an event for external consumers, not within the cargo system, which the internal services that needs to process. Say some other external system which wants to listen to the events which are generated within our cargo system. We can publish those events to a topic and a queue, a topic, and then external systems can listen in and implement. And yeah, this is the code snippet where we had sample code written to retrieve those events, or once the event is retrieved, we'll publish it to a external service.
I think a lot of it is leveraging underlying camel patterns, right,
Yeah.
to be able to publish the downstream events, and you can connect to different types of eventing solutions downstream as well once the processing happens there. Um, so we talked about capacity. Now let's talk about scheduling, right? Now, key aspect, right? Like before we jump into a schedule, like what does a schedule mean, right? Like basically, like we look at data which says, okay, hey, across the industry, right? Like most airlines, like if you look at it, they follow a standard pattern, which is to say like who is the carrier. You would see that in terms of the letters in front of the airline code itself. Then you would have a flight number. Typically, there would be a departure station code and an origin date, which is truly defines a unique set of data for a given flight, which is the carrier, flight number, the origin code, and the date. So like this has to be unique. You would not see the same combination happen, like in kind of repeat, right? Like for example, you may have the same station, right? Like say for example, you have LA, you may have flight number 812 for a given airlines, right? But they would not have the same flight departing twice a day. You have to have a different number. So that has to be managed. Uh, Now you would get events about the schedule itself, right? And we would need to understand, okay, what has changed, and do the processing accordingly, right? You may have like something like, say for example, there is a delay in time to say like I've got a flight which is scheduled to arrive, and we are all right now in winter, right? You're going to see a lot of delays happening, but it doesn't mean that the flight is cancelled, right? There is not a downstream impact to the capacity. It's just that the flight has been delayed. But there are some extraneous situations where you have to have more clever handling of how the situation is, right? Let's talk about them, right? If I'm doing a cancellation, right, for example, then all the booked airwables have to be updated so that they can be rebooked onto another flight, right? And impacts have to be understood, right? So it provides the airlines the ability to handle that. The second part is time changes or change of aircrafts. These are like pretty standard details, but aircraft change could have an impact. Like say if I'm going from a wide body large plane to a smaller plane, that means the amount of cargo that I can carry is going to be lesser. Similar with people. So then there has to be a prioritization of what cargo would go in the new flight. So that information has to be handled. So the system has to be able to update and inform business that hey, this is the change, these are the impacted the cargo bills itself, right? And then there are situations like a diversion or a flight in trouble. Right now, these are very rare situations which are happening, but there are a lot of security regulations when this happens, and information needs to be managed there. Uh, Now, what we are looking at is right a kind of a flow, a state flow in terms of the available status itself, around how the states are managed, right? And how we are looking at various states. Like say, for example, a flight has gone into arrived, but there may be a discrepancy, right? Or I may be in the manifested state. I may have like a challenge here in terms of delays, right? So what are the various events that can be triggered are depicted here. Now let's talk about some of the key components here. Ranjan, you want to talk about the key components here?
Yeah, so this is similar to the capacity model that we looked at. So we reuse majority of the classes or components which we used in capacity for flight schedules as well. Yeah, Mukund, if you can go to the next one. Yeah, so this is in detail explanation how the implementation was done. If you look at the option here, we were doing a CQ as well as the polling approach, and initially, but later we moved on to the eventing checkpointing approach, where we go retrieve the events and then start processing. So this is continuation of the previous slide that we looked at for the capacity. Um, yeah, this is in detail. Can you go to the next one, Mukund? Yeah, I think these we have already covered. Yeah, this is again, it's already covered there previously. Yeah, so this is the master slave Akka cluster that I was referring. So through remoting, say, initially all the masters and slave, they form a cluster, and then within master we had configured a OQL, which will retrieve all the events, and then it will start distributing the work across these various nodes, slaves and master node. And we had configured to process in master node as well, to make sure whenever there is a high load, we don't want one node to be idle. We wanted even the local routes to be configured, and that's how it was done.
So I know we are like close to finishing on time here. Um, the challenge here, right, typically we see, right, is there is like a pretty significant evolution as we have seen, right, with extra factors that we've seen with COVID. A lot of business changes which are happening, and so many changes which come in, which means like hey, suddenly a situation happens, uh, schedules have to happen, plus with weather there's a lot of changes which are happening. So the solution scalability needs to be factored in, right, when we are building this out. And truly, right, like when we are looking at building these solutions for an architecture uh, which is continually evolving, right, we believe like non-blocking approaches needs to be that foundational piece. Niranjan, any final thoughts from you?
Yeah, I think Mukund, you covered it.
Okay. I know we are kind of out of time here. I do appreciate you know the summit team, the Reactive Summit team and Lightbend team for giving us this opportunity, and their entire support team for helping us set this up. Appreciate the support. We've got a set of questions which were asked in chat here. I will try to take that time to ping people individually. I'll work with our organizers to respond back. Let me stop sharing. I know there is the end of day session here. I will hand it back to the moderators.
Oh, well
Hey
done.
Josh, how are you?
Oh, that was intense. Okay, well, thank you so much for a great session. Let's see here. Are there, do we know if there's any questions?
Yes, Josh. I think there are a few questions here. I would request the moderators to handle some of these.
Okay, let's see
Uh,
here.
so I think that the question from Vamshi as how many actors were running in each node. I think this depended on the type of actor system. Like in some of the smaller ones, we had like I think like Niranjan, do you remember like was it like 4 or 5? Like it was like a smaller number, right, of actors.
Yeah, it was around four to five actors per node
Yeah.
Cool.
on a
And
smaller one.
Tamara has a question around why did you need to mix Spring into the solution? I think there were two aspects. One, I'm pretty sure like was in the adapter side where we use Spring to create the adapters so that the data could be persisted. It was not truly on the eventing side, but it was more on the persistence side. Niranjan, do you want to add more to this?
And second one was on the Gemfire integrations. So Gemfire teams recommended to use the Spring integrations there.
Well, I'm a fan. All right, good stuff. Well, thank you so much, everybody, for that. I think we've gotten all the questions, and if not, I'm sure you gentlemen have given out your Twitters. I hope Twitter profiles and all that stuff.
Yes, it is there. We will share the slides as well, Josh. It will be shared. We'll work to the organizing team to share that.
Rock on, very good.